Hi, my name is Valerie Dagley, and this summer I was funded by the University of Oregon Center for Undergraduate Research to perform a 10-week research program led by Professor Hank Childs, who's a professor in the computer science department. Our research was focused on a new technology called Web GPU, which allows the web to be used for high performance applications. Our research was specifically focused on if this works, if it's viable, and if it is feasible to create these high performance web applications. So there's a lot of terminology in that research question, and a lot of hardware resources that we actually have to go over. So I'm going to start with a quick introduction. Now, web applications are becoming increasingly central to modern software. Anything that you can access through the web is a lot easier to access through than things that you have to install on your desktop. Um, I created this presentation in Google Slides. I created a poster for this research in Canva. They're just more and more common. Unfortunately, the web is slower. It often is 5 to 10 times slower, just due to the nature of how a web browser works, the security required for a web browser, and a whole bunch of other things about the history of web browsers that have caused them to be often 5 to 10 times slower than desktop hardware, than desktop applications. So this causes a small problem because if we want to do high performance applications such as data visualization, we end up running into a performance issue. We can't do those in real time. Now, this new technology, Web GPU, is released in April of 2023 for use on modern Chrome versions, on Windows and Mac OS. This Web GPU technology allows us to utilize modern hardware, the GPU specifically, to be able to do high performance applications. Um, or in theory, it does that. Um, Now, 3D data visualization, the specific focus of our research, makes use of these difficult calculations that are made much easier by the GPU, and we'll go into why that is in just a moment. All right, so just for some background, modern computers are made of two main processors. You've got the CPU and you've got the GPU. The CPU is good for sequential operations and it's good for extremely complex operations. It is the older of the two pieces of hardware, and it's used for everything from your OS to all of your programs. Everything that you interact with on the computer is going to be run through the CPU. It's the central processing unit. You've also got a second piece, which is the GPU, which is more specialized hardware. The GPU does simpler operations, but it does them in parallel, meaning it can do hundreds of operations at once. It's way faster for when the same operation needs to be done repeatedly, which makes it very good for its initial intended use, which was graphics. Computer graphics requires you to do a lot of the same calculation over and over. Every single pixel requires hundreds of calculations in some cases, and the GPU is very specialized for that. Now, the GPU in the past 10 years has actually been discovered to be useful for a lot of things. There's actually a lot of different calculations that require you to do one thing over and over. One of these is matrix multiplication, which is used in neural networks, and that creates things like modern things like ChatGPT. Anything AI is actually a cover term for neural networks, which require GPUs to run because it needs to do lots of things in parallel very quickly. It's also good for things like physics simulations. It allows it to do large physics simulations like for movies and for games. It's good for data visualization as we are testing. And it was used for cryptocurrency when that was a very large thing, because the blockchain requires some of those complex operations. All right, so what did we actually do for this research? So we decided we're going to answer our guiding question, which is it feasible to create a high performance application on the web um, using this new web GPU technology? Um, and we decided to implement a very simple common data visualization method using the GPU. This was called particle advection, which is basically you put a bunch of particles into a 3D vector field and watch how they move around. So it's like putting a bunch of dust particles into the air and watching how the air currents move those dust particles through a room. This data visualization method um, requires you to do a very simple calculation over hundreds or thousands of particles, which makes it very well suited for the GPU because it's good for parallel computing. We went ahead and used Rust and WebAssembly. These are two relatively modern technologies. Rust is built for safety, security, and performance. And WebAssembly is a modern thing that allows us to use Rust, which is typically a compiled language, meaning it does a bunch of the calculations up front to make it faster. It's a compiled language, which means that typically it wouldn't be able to run on the web. But WebAssembly is a technology that allows lots of different languages, C, C++, lots of different languages to run on the web. We chose these two technologies because it allows us to create a single program that we can run both on the web and the desktop with minimal differences. This means that I only have to write one program and then I can run it in the desktop version and test how it runs there. And then I can, with very few changes, I can then switch it to utilize web GPU and run on the web on my Chrome web browser, and make it able to also check the performance there. That just prevents us from having to deal with a lot of independent variables. We're pretty much only changing the way we're running this application. The application stays almost identical. So to actually do our testing, we went ahead and ran our particle advection algorithm on a very large number of particles, and we measured the amount of time it takes to render and compute the particle advection system on each frame. So each frame is the pictures that are presented to you. We measured the amount of time it takes to compute all of the particle advection algorithm, and then how long it takes to also generate the frame that's shown to you. And then we did that over increasing stress loads, just to see how the application scales for very stressful GPU programs. Just as a reference, we went ahead and did these tests over roughly 10 seconds, and then we took the average frame time from that test. So I'm going to go ahead and do a quick demo of our application. It's going to be run on the desktop just because it's easier to show on this Zoom. But the web version is identical in visual and and very similar in performance. So these pictures that have been on these slides are directly taken from this application. And just going over these pictures really quickly, this is a 100 by 100 grid of particles, and this is taken over 4 pictures. This is the first one going to second, third, and fourth, and it's showing how these particles are getting moved by a 3D vector field, or like the wind currents in this room. So we can see some of the particles start to separate and move towards these little sink spots where a bunch of particles gather together. They also start to go up and down because it's inherently a 3D data set we're working with. So I'm going to go ahead and run the program and see how it looks. So here's our program. It runs very smoothly. It's running at shorter than real-time speeds with no issue. That was 100 by 100 particles all being moved. I'll go ahead and run it real quick because it went pretty quickly. And so that was our program, and it runs identically on the web. So let's go ahead and get into some of our results from our actual research question. So again, we're trying to test if it's feasible to do these GPU computations on the web using web GPU. So using our test data, we actually went ahead and graphed the amount of time it took versus the amount of steps or the amount of stress that the GPU was under. And looking at it, we've got the red native bar, that's our desktop performance. And then we've got the blue web line, which is the performance run through my Chrome web browser. We actually observed a very interesting thing. You might remember I mentioned a 5 to 10 times slowdown. That's actually for CPU operations. In our testing, we discovered that the GPU actually allows us to utilize it very well. And it has only the slowdown of the CPU operations. You can see our CPU difference here between the overhead of the web browser and all of those things. This is extremely promising. These are really interesting data, which allows us to do a lot more. And so it's really interesting to see where this goes. In the future, it'll be interesting to test things like adjusting the number of particles and seeing how that affects performance, just to see how things parallelize. Also, just continuing and refining our process. So this was funded by the Center for Undergraduate Research and Engagement. I would like to acknowledge the assistance of Professor Hank Childs, who was my faculty mentor. He led me through this research, encouraged me throughout, told me what I needed to look into and how I should do that. I also worked alongside PhD students Manish Matai and Meganto Majumder. They were immensely helpful. They gave a lot of good feedback and did a lot of testing on their own machines. Super helpful. I also worked alongside another undergraduate student, Peter Nelson, and he did parallel work in this field, which was very interesting to see as well. Now, I do need to go over how this research experience was. This was great. The Center for Undergraduate Research gave me a grant to pay for my living expenses over the summer so that I could do this research while living in Eugene near the University of Oregon. And it was an amazing opportunity. I got to live alone in an apartment for the first time, which is a whole new experience and would not have been possible without their funding. It allowed me to have access to my faculty mentor, have access to all of the university's supplies. It was super useful. It was an amazing experience, and the experience is still continuing because I will be participating in the University of Oregon Undergraduate Research Symposium on May 23rd, 2024. I'll be presenting this research in the form of a poster. And I've got this poster coming up next. But yeah, I just want to thank the Center for Undergraduate Research for this. And I'm going to go ahead and pull up this poster and leave it there for a solid minute, just so that it can be viewed if you want to view it. Go ahead and pause if you need to. So this is the poster. It's a little wordy. It's meant to cover a lot of the things that I talked about in this presentation, and may be adjusted before the actual research symposium. But here's the general poster. Thank you.